Hi, I'm Shamali Chatterjee from Purdue University, and I present OptimusCloud, heterogeneous configuration optimization for distributed databases in the cloud. This is in collaboration with Google Brain, Microsoft, and Adobe Research. So the problem here is configuration of cloud-hosted databases need to be optimized because increasingly you have NoSQL databases being hosted on the cloud, and these have myriad configuration parameters that need optimization for performance, consistency, and durability. Now, if you consider the configuration parameters of these cloud-hosted databases, one dimension is the sample parameters for NoSQL databases, such as cache size, compaction method, etc. And another dimension is the sample parameters for these cloud VMs, which could be number of cores, memory size, network bandwidth, etc. Right? So combining both sets of configuration parameters is helpful, but it produces this large configuration space. For example, Cassandra, which is a popular NoSQL database, has 25 plus performance-sensitive configuration parameters, and Amazon EC2 public cloud has 133 instance types or sizes that vary in price by a factor of 5,000x. And also there is this dependency between these configuration parameters. So in this, we do profile Cassandra's performance on different VM types or instances. And we show a violin plot for the performance, that is throughput, of the best, default, and worst database configurations across different EC2 VM types. So to do this, we benchmark one Cassandra server with a 30-minute trace from one of 3 workloads on 6 different EC2 VM types. And for each type, we use 300 different database configurations selected through grid search. And we see that there is up to 74% better performance over default configuration, 45% on average. And the best configurations, they vary with the VM type and size. And for the 6 different VM types, there are 5 distinct best database configurations. Now, a problem is the dynamic workloads. So these cloud-hosted databases have to deal with these dynamic workloads that change unpredictably over time. For example, in Cassandra, with a large working set size, reads demand instances with high memory, while writes demand high compute power and fast storage. So changing the configuration at runtime for NoSQL databases, which are stateful applications, has a performance impact due to the downtime during this reconfiguration. So can we just reconfigure a subset of servers to minimize this reconfiguration performance hit and achieve maximum performance per dollar while meeting the service level agreements related to availability, etc.? Right? So we introduced this concept of reconfiguring a subset of the instances, resulting in heterogeneous configurations which prior work does not address. So our solution, OptimusCloud, jointly tunes NoSQL database and cloud VM configurations for dynamic workloads. There are 3 animating insights. One, as we saw through the violin plot, we need to jointly reconfigure both the database and VM configurations. It results in an explosive growth in the search space. We have these heterogeneous configurations, which are helpful from a cost-benefit standpoint. And for a particular NoSQL database, it is possible to create a machine learning model to map the configuration parameters to the performance of that server, and from that, the performance of the overall cluster. So these are the differentiators for OptimusCloud from Ernest, Cherrypick, Selector, Rafiki, and Sophia. These are prior works. And we see that OptimusCloud supports both single server prediction, multiple server prediction. For multiple server prediction, both homogeneous and heterogeneous, and does joint optimization. In addition, it also has this cost-benefit analyzer to handle dynamic workloads. Evaluation in Cassandra using 3 different applications, NG-Rust, HPC simulated workload, and a real bus tracking application called Hiramisu. Using these 3, we see that OptimusCloud achieves up to 86% better performance per dollar over the homogeneous reconfiguration solution. For OptimusCloud, it achieves up to 173% and 130% over cherry pick and selector due to its ability to find heterogeneous configurations. And again, over Sophia, because of the joint optimization of the key value store parameters and the VM instance types, it achieves up to 212% better performance per dollar. So these are the takeaways, where you have joint optimization, creation of heterogeneous configurations using a novel concept of complete sets, and we found that OptimusCloud outperforms all prior works by quite a bit in both performance per dollar and tail latency. Thank you.